So here we can ask ourselves, hey, what is my takeaway? What have I learned here so far? And only you can answer that. So please go ahead and fill out your takeaway. And even more important, as you heard me say before, is what is still muggy to you and how can you get clarification. Of course, in this case, it's probably very easy because I explained everything in the text for you. So maybe you just read it again. But please be sure that you have a solid understanding of this, because keep in mind, this is basic knowledge in lecture 0. That means that this is knowledge that you need at the back of your hand. You need to do this in a fraction of the time later on to solve your problems. So don't skimp on this. Go ahead and understand this. But once you buy into that idea, I think we are ready to check off our checkpoints here. Let's go ahead and understand that we remember our trigonometric basics, and that it's generally best to measure angles from the positive x towards the positive y-axis. That is something that I was trying to make clear here to you. Also, we hopefully recall the sine law and the cosine law, and if not, you find all the information that you need in these pages. Then we understand that the sine and the cosine law apply to triangles that have a random angle and a random side length. So often I see students apply these to angles with right angles because for some reason they think trigonometry applies only to right angle triangles. But in reality, this is exactly designed to deal with arbitrary triangles. And of course, you find why that is above. We realize that the cosine law and the sine law can be derived, and you can derive this yourself even by sectioning and by expanding any of those random triangles into many right-angled triangles. So you need, of course, a solid understanding about right-angled triangles if you even want to deal with non-right-angled triangles. But I can check that off now. And in other words, we are now prepared for engineering mechanics problems that rely on trigonometry. And all of them actually do in one way or the other, but we are now prepared for that. Very important is that we understand the 3, 4, 5 triangle, and that this includes a right angle. And there's another one, by the way, that you will see later on. There is one that is actually a 5, 12, and 13 triangle. So that triangle, you would have a side that is 12 long. Then you have a right angle to that with a side that is 5 long, and they are connected with a hypotenuse that is 13 long. So those also make a right angle triangle, and it behaves the same way as the 3, 4, 5 triangle. But you will see more of those later, and of course we buy into that idea, so we can now check that off. In other words, I now fully master the concept of similar triangles, and I can apply those to my engineering mechanics problems. So we are now ready to really conclude this 0 lecture, and now we have all the pre-knowledge in place so that we can start solving engineering mechanics problems. Therefore, I will see you in the next lecture. Until then, stay safe.